Uh, so we will continue with the topic, and today we will cover two methods because today is the last lecture. So we will be covering the Newmark method, and we will be also covering the Wilson theta method. Now here, this Newmark method is sometimes also called as Newmark beta method for the direct integration. Like central difference method and Hubble method, the solution is, or the solution procedure is divided into two parts. One is the initial calculations, and the second one is the stepwise calculations. Okay. So in the initial calculations, like other methods, the first step is we have to generate the stiffness matrix, mass matrix, and the damping matrix. But whenever numerical comes, these matrices will be given to you, and if they are not given, then you can always assume the values. Then in the second step, you have to find out what are the initial conditions, and mostly the initial conditions are given to you. Initial condition means the displacement, velocity, and acceleration at time is equal to 0, okay, or at any time where the problem is about to start. Then here in the Newmark method, third step is basically the calculation of integration constants. So here two new parameters are coming into picture. One is the alpha and second one is the delta. So alpha and delta values are the constants which will be given in the numerical itself. Okay, mostly if they are given, and if they are not given, in that particular case you can assume the value of delta as 0.5 and above value. Okay, so any value greater than 0.5, that you can assume for the value of delta. And once the value of delta is assumed, you can get the value of alpha as 0.25 into zero point 0.5 plus delta whole square. Okay, so this is a standard expression which you can use to calculate the value of alpha. But most of the time this alpha and beta value are alpha and delta value, they will be given to you. Now, based on the values of alpha, delta, and this delta t, okay, you will be getting the integration constants, and integration constants are ranging from a1 to a7. So total 8 integration constants are there in the Newmark method. So you have to calculate these values based on the formulas which are given to you. And in the last step of the part 1, that is the initial calculation, you have to calculate the effective stiffness matrix. So effective stiffness matrix is very much similar to the effective stiffness matrix which we have seen in the Hobart method. Okay, that is K equals to, or the effective stiffness matrix equals to K plus A0 times M plus A1 times C. Okay, so this completes the initial calculations, and then we have to go for the stepwise calculation. So for every step you need to find out the or you need to follow certain process so that you can get the values of the unknown displacement, unknown velocities, and unknown acceleration. So the very first thing which you have to do is to find out the effective load vector at a particular time. So let us say if time is 0, then we have to start working on the calculation of the response at delta t. So what will be the load vector at delta t, that we have to consider, and we have to find out the effective load vector using this expression. Once this effective load vector is calculated, you can solve the stiffness matrix, that is effective stiffness matrix into displacement at delta t equals to the effective load vector at delta t. So once you solve this, you are going to get this unknown displacement. Now using this unknown displacement, now you can calculate the values of the acceleration, and you can also calculate the values of the velocities. Okay, so here the value of acceleration is calculated first because this value is required in the calculation of the velocity. So earlier, if you remember, in the central difference method, the calculation of the acceleration and velocity, they were optional because the values of acceleration and velocity are not required in the next step. But here the values of acceleration is required in calculation of the velocity. So if you want to calculate the velocity, first thing you have to do is you calculate the acceleration first, and then you get the values of the velocity. So these are the standard equation which you have to follow. and then we can get the values, or you can get the response of the structure using this Newmark method. Okay, so it is also called as Newmark beta method. So what we will do, we will continue with the problem which we have taken earlier, and we will try to solve the same problem using this Newmark method. Okay, so let me change the presentation pattern, and let me shift to the this window. Okay, I hope my screen is visible. Yes.
Yes, sir.
Okay, so in the earlier class we have been working on a problem which is like this, that is 4 times acceleration. Let me go in the draw mode. Okay, so we are working on something like 4 times acceleration plus 2 times the velocity plus 1 times the stiffness equals to 8. So this we have seen the time period t was given to you was 1 second. Okay, and delta t is capital T divided by 5, which was coming out to be 0.2 seconds. Okay, and in this particular problem, since this is a Newmark method, the value of alpha and delta are given to you. Okay, so value of alpha is given to you as 0.25, and value of delta is given to you as 0.5. Okay, another information which is given to us is at t is equal to 0. So initial condition is given to you. So when t is equal to 0, your your unknown displacement, or the displacement is 0, as well as the velocity is also 0. Okay, so now let us try to solve this. So in the part 1, okay, so in the part 1, what you have to do is you have to identify the stiffness matrix, mass matrix, and the damping matrix. So in this problem it is given to you, so your K matrix is given to you as 1. Okay, then the damping matrix C is given to you as 2, and your mass matrix M is given to you as 4, and the force vector R, this is constant. Okay, so this is every time this is constant, and this value is given to you as 8. Okay, so at time, so at t is equal to 0, what is given to you? The velocity and the displacement is given to you. So u is equal to 0, u dot is 0, but we don't know what is the u double dot. Okay, so for this purpose what we generally do, we take the equations which are there available with us. So we take this equation, and then we go for 4 into this u dot, oh sorry, u double dot. So this is unknown, plus you have 2 times u dot, so this value is 0, plus 1 times u. Okay, so this value is also 0, equals to 8. And so if you solve this, you are going to get u double dot value as 2. Okay, so this value you will be coming, you will be getting this as 2. So your initial calculations are now done. Okay, and the unknown value, the initial conditions are also known. Okay, so now what you have to do is you need to find out now the integration constants. Okay, so while while calculation of the integration constant, let me write down the equation for a0. A0 is 1 upon alpha times delta t square. Okay, so 1 upon alpha times delta t square. So can anybody give me the values over here? Somebody? How much is this? So this is 1 upon the alpha value is 0.25
100.
into 0.2 square. This is 100, right? Okay, then we have a1 also. Okay, so a1 is delta divided by alpha into delta t. So this is delta into alpha into delta t. So your delta value is 0.5. Okay, alpha is 0.25 into delta t is 0.2. Yes, a1 please.
10.
10. Okay, then we also need to calculate the integration constants a2. So a2 is 1 upon alpha times delta t. Okay, so this is very much similar to a0, only thing is the square term is missing. So this is 1 upon 0.25 into zero point 0.2. So ये कितना आ रहा है? 20 I suppose.
20.
Okay. Hmm. Then we have a3 also. Okay, so a3 is coming out to be 1 upon 2 times alpha minus 1. How much is this? कितना आ रहा है a3?
1. 1.
1. Okay, then we have a4 also. So a4 equals to delta upon alpha minus 1. So this is delta upon alpha minus 1. How much is this? I think this should also come as 1. बराबर है?
Yes, sir.
This thing a5 is delta t divided by 2 into this is delta minus alpha minus 2. Give me this a5 now. a5 anybody?
0.1.
Sorry,
0.1.
नहीं कुछ तो गड़बड़ है.
Sir, 0.
0.
0 0
Sir,
right.
0.
Yes, 0 correct. a6. Okay, so a6 is delta t into 1 minus delta. So this is delta t into 1 minus delta. How much is this?
Sir, 0.15.
0.1 आना चाहिए, 0.15 नहीं आना चाहिए.
Yes, sir. 1.1.
Sir, 0.1.
Okay, and a7 is delta into delta t. Okay, so this also comes out to be 0.1. Okay, is it so? Please check.
Yes, sir.
Fine. Now the last step in the first part, that is we have to calculate the effective stiffness matrix. Okay, so your effective stiffness matrix can be calculated as something like k. Okay, k equals to, just now we have seen it is k plus a1 times m, a0 times m, sorry, not a1 times m, plus a1 times c. Okay, so if you substitute the values over here, so your stiffness matrix comes out to be 1, a0 is coming out to be 100, and your mass matrix we have seen as 4, plus a1, the value of a1 just now we have calculated as 10, and the c value is 2. So your effective stiffness matrix will be, so this is 400. Okay,
21.
400 plus 40
21.
plus 1. Sorry,
421, sir.
421. Okay, so this is the completion of the first step. So you can see in the first step we have calculated the effective stiffness matrix, all the integration constants, and we have already calculated the uh, the what you say, the initial conditions. Okay, so this completes the first part. Okay, so from here now we will be going for the stepwise calculations. Okay, so for this purpose what I'm going to do is I'll just insert one small table, so that wherein I can write the values over here. So here I'll write time. Okay, so this is my time. So time right now I have the zero values, then I'll be working on delta t, that is 0 0.2 and then 0 0.4. Okay, so here I'll be writing down the values of u, here I'll be writing down the u dot values, and here I'll be writing down the u double dot values. So right now if you refer the initial conditions when t is equal to 0, so here you can see in this portion, so here you can see the displacement velocity both are 0 and acceleration is 2. So this is 0, this is 0 and this is 2. So now I will be calculating the response of the structure for the values of time, that is delta t. Okay, so I need to calculate what is u. Okay, I need to calculate what is u dot. Okay, and I need to calculate what is u double dot. Okay, so this is my aim. So for this purpose what we have to do is we have to follow the stepwise process. Now in this stepwise process, first thing we have to do is you have to calculate the effective load vector at that particular time interval. Okay, so here I'm just copying and pasting the equation from the notes over here, so that the efforts can be reduced. So here you can see the effective load vector, the values of effective load vector is depending on what is the load value at the delta t. So here you can see what is the r value at delta t. So r is not going to change because in the numerical it is given as same. So this value is 8. The mass matrix we have already calculated, or it is given in the problem as 4. A0 value we have calculated as 100, that is 100. Now here you see I need to calculate what is the displacement at t is equal to 0. So here if you refer this, so displacement at t is equal to 0 is given to you as 0 over here. Okay, so I'm going to take substitute these values over here. So here this value is 0. The A2 value, so A2 value we have just now calculated as 20. Okay, and the this is the velocity at t is equal to 0. So if you refer the table, the u dot at t is equal to 0 is basically 0. Okay, then A3, so A3 value is I think we have calculated A3 value as 1, and this is the acceleration at t is equal to 0. This also we have calculated this as 2. So you see this is basically, here is a bracket over here. Okay, so this entire equation is multiplied by m. Then we have another equation where the entire equation will be now multiplied by c. So c is your damping matrix and the value of c is given to you as 2. The a1 value, so a1 value is already calculated as 10. Then we have the displacement at t is equal to 0, which will be 0. The velocity at t is equal to 0 is also 0, and the acceleration at t is equal to 0 is 2. All we have to do is just substitute the values of a4 and a5. So a4 value is basically 1 and a5 value is basically 0. So you can refer that table or your earlier notes, you will find these values. Okay, so this is going to give me the value of the effective load vector. Okay, so this is the effective load vector at delta t. So time is equal to delta t. So can somebody give me the value of this? It's a simple calculations.
Sir, 16.
Yes, 16. Okay, so this is going to give me a value of 16. Okay, now so once this value is known, what we have to do is you have to generate the effective stiffness matrix equation. So your effective stiffness matrix equation is something like k. Okay, so your effective stiffness matrix K into the displacement at delta T. Okay, so that is T is equal to delta T equals to the load vector, or rather I should say effective load vector at T is equal to delta T. So if you solve this, so earlier we have already calculated the effective stiffness matrix as 421. Okay, not yeah, 421 into, you have the displacement at delta T equals to the effective load vector just now we have calculated as 16. So if you solve this, so you are going to get the delta T term, or the displacement at delta T. How much is this? That is 16 divided by 421.
0.0380.
Okay, 0.038. Okay, so this is the displacement. Okay, so let me drag this table down. And so what we have just now calculated is the value of displacement at t is equal to 0.0 at t is equal to delta t. So this is 0.038. So this is the displacement value. Okay, let me increase the font of this so that you can see these values correctly. Okay, so what we have just now done is we have just calculated the displacements. So now we will be focusing on how to what are the values of the acceleration and velocity. So like I said earlier, in this particular method, we have to calculate the acceleration first, and then we have to get the value of the unknown velocity. So for calculation of the acceleration, the equation is given to you. It is something like this. Okay, so this is the acceleration value. So this is the acceleration at u as minus delta t, or sorry, this is plus delta t. This is not printed properly, so this is plus delta t. So here the value of a2, sorry, a0 we have to find out. So a0 we have already calculated as 100, and this is the value of the velocity, this is the value of displacement at delta t. So displacement at delta t, just now we have calculated this value as 0.038. Okay, minus the displacement at t is equal to 0, this is already 0. Okay, you can refer the values from the table, minus a2. So this value of a2 is given to you, or we have calculated as 20. Then here you can see this is the velocity at t is equal to 0. So velocity at t is equal to 0 is already 0. Then we have minus a3. So value of a3 is 1. And then we have the acceleration at t is equal to 0. So acceleration at t is equal to 0 we have calculated as 2. We can refer this. Okay, so just give me the values now. So this is going to give me the value of acceleration, okay, at delta t. So that is time is equal to delta t. Yes, please someone give me the value, please.
Sir, 1.8.
Yeah, 1.8, correct. So this value,
सर इन दिस वी हैव टू नो, मतलब इसके बाद वेलोसिटी फाइंड आउट करेंगे सर.
sorry,
यू डॉट वैल्यू.
इसके बाद कैलकुलेट करेंगे.
ओके सर.
Okay, so because this value, the acceleration value is required in the formula of the velocity. Okay, that's why it is required. So here the value of acceleration is coming out to be now 1.8. So now let us calculate the velocity now. Okay, so your velocity equation is like this. Okay, so this is the velocity equation. So now in this velocity equation, so the value of velocity at t is equal to 0. So you can see this is the velocity at t is equal to 0. This is now 0. Then we have a6. So if you refer your earlier calculation, so value of a6 is calculated as 0.1. Now here you see this is the acceleration at t is equal to 0. So acceleration at t is equal to 0 is 2. Then this is a7. So a7 is the integration constant, its value is 1. Now here you see this is the acceleration at t is equal to delta t. तो ये हमको यहाँ पे already we have calculated this. So if you don't calculate the acceleration first, you won't be able to get the velocity. So this value is now 1.8. So ultimately you are going to get the velocity at delta t. T is equal to delta t. How much is this? It's a simple straightforward calculations.
So 0.38.
Yes, this is 0.38. Okay, so here this is 0.38. So this is how you can get the response of the structure for the first delta t. So delta t term is 0.2 now. Okay, I hope this is clear to everybody. Any questions? Yes, students, any questions? I'm guessing not.
No, sir.
Okay, so now I want all of you to find the response of this structure at delta t, that is 2 delta t. Okay, so this is 0.4. So at t is equal to 0.4, I want you to calculate the displacement, I want you to calculate the acceleration, and I want you to calculate the velocity. Okay, so for this purpose we will be using the same equations which we have used earlier. Okay, now only thing is everything is incremented by delta t. Okay, so for example, if you take the value of effective load vector, so effective load vector will be now increased, or the every delta t will be now increased by one more delta t. So this is the expression which is there in front of you. Then you can use a expression, uh, that is the stiffness expression over here. So this expression can be used to calculate the value of the unknown displacement, and further you can use expression to calculate the acceleration. So you can use this expression to calculate the acceleration now. Okay, and lastly you can use another expression to calculate the velocity. Okay, so you can use this as the velocity expression. Okay, so all the expressions are there in front of you. Now you can refer your notes and you will find everywhere the delta t term is incremented. Okay, so wherever there is a time term, so earlier if it is time is equal to delta t, so everything is now incremented by delta t. So जहाँ पर भी तुम्हारा delta t था, now it will become 2 times delta t. Wherever there was time is equal to 0, so it will become delta t. Okay, so all the equations are there in front of you. Please solve this, and meanwhile I'll just take your attendance. Okay, please solve this everybody. Roll number 2, Mrunal Mehta. I think she is absent. Ketan Mose, roll number 9. I think he is also absent. Roll number 11 and roll number 12, Mohit Gupta and Jaiswal, both are present. Both are absent. Then we have 13, 14, 15. Roll number 16, Shashwat. I think he is also absent. 17 and 18. Okay, that's it. Nakul Bakde, Suwan Paul, is it done? Anybody? Yes, anybody? Values, please. What is the effective load vector?
61.636.
Let me check. Huh? It is something like 62.3. Please cross.
62.32.
Yeah, 62.32. Correct.
Yes, sir.
So this value, your effective load vector R, is coming out to be 62.32. Okay. And how about this one? If you solve this, what is the displacement at 2 delta t? Anybody?
Sir, 0.148.
Let me check. Yeah, 0.148. Correct. So all you can do is here you can write 0.14 and 8. Then you have to calculate the acceleration. Okay, so this is the expression for acceleration. So without acceleration, you cannot calculate the velocity. So anybody having acceleration value? Anyone? मॅडम क्लासमध्ये नंतर बोलतो. Yes, anyone? Acceleration value?
Sir,
Shall I write down?
1.6.
Yeah, 1.6, correct. Okay. And lastly, if you solve this, the velocity at 2 times delta t. So here I need to write down 1.6. So based on these values, now you can get the velocity value also. it done? So it's a simple expression. So if you substitute the values, you should get the value of this velocity at 2 delta t as 0.72. Okay. And likewise, what you can do is you can solve the rest of the values for calculation of the response of the structure. So you can proceed further with the similar calculations. Only thing is all the equations now will be incremented by delta t. So you can get similarly what is the acceleration, velocity, and the displacement value for 3 times delta t. Then we can get it for 4 times delta t, and so on. So if you solve this, so you will get a very nice table wherein you can see how the displacement is changing with time, okay, how the velocity is changing with time, and how the acceleration is changing with time. So you see the displacement is basically increasing with time, the velocity is also increasing, but however the acceleration is reducing with the time. So this is all depending on the type of the problem. You will get a variation in the values. Okay, so I hope this is clear to everybody. Any question as far as this part is concerned? Yes, anybody, or shall we proceed ahead with the another topic? This will be the last topic. Any questions, please? Yes, students.
No, sir.
Okay. So coming to the last part, so I'll be quick in this particular topic. This is the last method, and this method is called as the Wilson theta method. Okay. So here in the Wilson theta method also, the process of getting the response of the structure is once again divided into two parts. One is the initial calculation and second one is the stepwise calculation. In the first, that is the initial calculation, what you have to do is you have to find out the stiffness matrix, mass matrix, and C matrix, that is the damping matrix. So fortunately these matrices will be given to you in the problem. Then the initial conditions, that is what is the displacement, velocity, and acceleration at t is equal to 0. So most of the time this is also given. In the third step, you have to calculate the integration constants. So now here integration constants are a little bit different. So here there are 9 integration constants right from a0 to a8. Now here there is another term called as theta. Okay, so theta is the angle. So usually this theta value is given in the problem, and if it is not given in the problem, you can take this theta value as 1.4. Okay, so based on the delta t term and the theta value, you can get the value of a0, a1, a2, a3, a4, a5, a6, and a7, a8. All these 9 constants you can get the values. And then lastly, in the first part, we have to get the effective stiffness matrix. So effective stiffness matrix, the equation is same as the earlier two methods, that is the Wilson theta method and the Newmark method and the Hobart method. That is effective stiffness matrix equal to stiffness matrix plus a0 into m plus a1 into c. So this is the initial calculations, and in the stepwise calculation, you have to calculate what is the effective load vector at theta times delta t. Okay, here you won't be getting the values of load vector at delta t. Okay, here you will be getting the load vector at theta into delta t. So the equation is there in front of you. All you have to do is just substitute the value, and once these values are substituted, you get the value of load vector at theta delta t. So you can get a expression, or you can see this expression, and if you substitute the value, so in this values you will be getting a displacement value at theta delta t. Okay, not at delta t, theta times delta t. But we are not interested in the getting the response of this structure at theta times delta t. We are interested in delta t. So for this purpose, you have to follow these three expressions. Okay, in the first expression you will be getting the acceleration first. Okay, so acceleration at delta t can be calculated using this expression. Further, you have to use this expression to get the value of velocity at delta t, and lastly you will be using this expression to calculate the value of displacement at delta t. Okay, so here the first two expression they will be dealing with the theta times delta t, but the rest three expressions they will be giving you the correct values. Okay, I hope this is clear to everybody. बराबर है? So let us start with this method, and we will go for the solution, or we will find the response of the structure. Okay, so let me share it one more time. So here I'll be using another section. So this is Wilson theta method. Okay, so uh, okay. So I'll write down the numerical. So numerical is again the same numerical is there. Okay, I hope my screen is visible. दिख रहा है?
Yes, sir.
Is it visible?
Yes, sir.
Yes, sir.
Okay, so the numerical is same. Okay, basically, so your numerical is says something like let me draw this. So you have 4 times the acceleration plus 2 times the velocity plus 1 times this displacement equals to 8. Your u is 0, u dot is 0, where at t is equal to 0, and if you substitute these values, so you can also get the acceleration as 2. So okay, this we have done several times, so I'm skipping this particular step. And we already know what is the value of m. So this is the value of m, this is the value of c, sorry, this is the value of c, this is the value of k, and this is the value of r. Okay, so I hope this is now clear to everybody by now. Okay, okay, let me just redo it. So this is the value of 2 and u dot. Okay, this is the value of c. Okay, so now we have to do the initial calculations. So in the initial calculations, all we have to write down this is m value is 4, your c value is 2, your k value is 1, and your r value is 8, and the displacement at t is equal to 0. Okay, so at t is equal to 0, the displacement is 0, the velocity is 0, and the acceleration is 2. Okay, so this we have calculated several times, so I am skipping this particular step. Okay, so this part is done. Then the value of theta is given to you in the problem. Okay, this I missed while writing the problem. So theta value is usually is taken as 1.4. So in the numerical itself, let me write down the value of theta is given to you as 1.4. Okay, so based on the values of theta, now you have to calculate the integration constants. Okay, so the very first integration constant is a0. Okay, so your a0 is 6 divided by theta into delta t whole square. Okay, so this is 6, theta is 1.4, delta is 0.2 whole square, and if you solve this, you are going to get something like 76.53. Okay, similarly you can get the value of a1 also. So a1 is 3 divided by theta times delta t. So if you substitute these values, so you are going to get 10.71 as alpha 1. Your a2, oh sorry, a1, so your a2 is 2 times a1. Okay, so your 2 times a1, it comes out to be 21.43. Okay, your a3 is something like theta times delta t divided by 2. So your a3 value comes out to be 0.14. Your a4 value is something like a0 divided by theta. So a0 divided by theta, so this comes out to be 54.66. Okay, then we have a5. Okay, so let me use this space. So your A5 is something like minus A2 times theta. So your A5 comes out to be minus 15.3. Okay. Then we have A6 also. So A6 is 1 minus 3 times theta. So this comes out to be minus 1.143. Then your A7, okay, not A5, this is A7. Okay, so A7 is delta t divided by 2, so this is zero point 0.1. Definitely it's a simple calculation. And A8 is something like delta t square divided by 6. Okay, so this comes out to be 0.006 and 7. Okay, so this is 6 and 7. Okay, so all these integration constants we have calculated. Then lastly we have to get the effective stiffness matrix. Okay, so your effective stiffness matrix K, okay, can be calculated as the stiffness matrix K plus A0 times m, okay, plus a1 times c. Okay, so here the value of k is 1. Okay, a0 just now we have calculated as 76.53. So your m is the mass matrix, its value is 4. A1 we have calculated as 10.71, and C is the damping matrix, that is 2. Okay, so if you solve this, so you are going to get the effective stiffness matrix K as 328.55. Okay, so basically these are the simple calculations. So with this you can complete the first part, that is part 1. Now we can shift to the second part. Okay, so in the second part we have to calculate what is the response of the structure at delta t. Okay, so when time is equal to delta t, we need to find out what is the value of u, what is the value of acceleration, okay, and what is the value of velocity. Okay, so let me insert a table so that you can get the values correctly. So insert table. Okay, so here I'll be putting the values of time. Okay, so time will be now 0, 0 0.2 and 0 0.4. And here we can have the u value, here you can have u dot, and here you can have u double dot. Okay, so this column is not necessary to me, so let me remove these columns. Okay, fine. So right now what is available with us is the displacement, velocity and acceleration at t is equal to 0. So this is 0, this is 0, and this is 2. So we are interested in calculating these three values. Okay, so for this purpose what we have to do is we have to first of all calculate the effective load vector. So here your effective load vector will be calculated, that is r will be calculated at theta into delta t location. Okay, so this is slightly different in this method. Okay, so for this purpose we will be using an expression which is something like this. Okay, so it's a quite big expression. So let us quickly substitute the values in this expression. So the value of r is given to you in the numerical itself, so this is not changing. So this is 8. The value of theta is 1.4. This is the load vector at t is equal to delta t. Okay, so this is t is equal to delta t, it is same load vector because this is not at all changing. And here at t is equal to 0, so since this is load vector is not at all changing, so this will become same, and this value will cancel each other, and this entire portion will be reduced to 0. So if the load is changing, then there will be certain difference. Anyway, so your mass matrix is basically 4. Okay, a0 value you have calculated as 76.53. The displacement at t is equal to 0 is 0. The a2 term, so a2 term is 21.43. The velocity is already 0. Then there is 2. So 2 is a constant term, and this is the acceleration at t is equal to 0. This we have already calculated this as 2. Okay, so there is a bracket over here and there is a bracket over here. Okay, anyway, then we have to substitute the values of c also. So value of c is basically 2. Your a1 is 10.71. Your this thing is 0 because this is the displacement at t is equal to 0. So 2 is a constant. Then we have a acceleration, or sorry, the velocity at t is equal to 0, it is also 0. So the value of this a 3 we have calculated as 0.14, and the acceleration at t is equal to 0 is 2. Okay, so if you solve this, that is the effective load vector at t is equal to theta times delta t. Okay, remember this is theta times delta t. So if you solve this, so you are going to get a value something like 24.56. Okay, so this is how you can get the value. Okay, then lastly, once this values is known, what you can do is you can generate the stiffness equation. Okay, so your stiffness equation is like this. Okay, that is the k into u equals to r. So your effective stiffness matrix is your k. Okay, so effective stiffness matrix we have already calculated in the initial calculations. So this value is coming out to be something like 328.55. Okay, so this we have already calculated. Now this is the displacement at theta delta t. So this will be unknown, but the load value just now we have calculated as 24.56. So if you solve this, you are going to get the displacement at theta times delta t. Okay, so this value is coming out to be something like 0.0747. Okay, so but we are not interested in calculation of the response of a structure at theta times delta t. We are interested in the theta t itself. Okay, so let me drag this table down so that you can see the values in the further calculations. Okay, so if you want to use this, or if you want to calculate this, the response of the structure at delta t, you have to calculate the acceleration first. Okay, so this acceleration can be calculated using this expression. Okay, so this is a standard expression of this Wilson theta method. So here this is the acceleration at t is equal to delta t. Okay, so all you have to do is substitute the values. So your a4 value is 54.66. Okay, and this is the plus term. Okay, it is not printed properly, this is a plus term. Okay, so this is the displacement at theta delta t. Okay, so displacement at theta delta t we have already calculated as 0.0747. Just now we have calculated. Okay, then there is a minus term over here, and this is the displacement at t is equal to 0. So displacement at t is equal to 0 is already 0. Okay, you can see over here. So this value is already 0. Then we have a5 term. So a5 term is 15.3. Okay, then we have the accelerate, this is the velocity at t is equal to 0. This is already 0. You can refer this is the velocity at t is equal to 0. Okay, then we have a6 term. So a6 is negative 1.143. So this we have already calculated, and this is the acceleration at t is equal to 0. Okay, so this is the acceleration at t is equal to 0. So this is the 2 value. So you can substitute this 2 over here, and if you solve this, all you are going to get is the acceleration at theta times delta t. Okay, so this value is coming out to be something like 1.8. Okay, so here in this table now I can write this value is 1.8. Okay, so using this expression, first we will be getting the value of the acceleration. Okay, then once the value of acceleration is known, you can start working on the velocity. Okay, So for velocity, the expression is there in front of you. Let me paste this. So this is the expression for the velocity now. Okay. So all you have to do is just substitute these values over here. So you can see the first value is the velocity value at t is equal to 0. So velocity value at t is equal to 0 is already 0. This is given in the problem. So let me write down 0 over here. Okay. Then we have the A7 term. So A7 is 0.1. Okay. Then we have a acceleration at t into also at t equals to delta t. So acceleration at t equals to delta t, we have already calculated this as 2. So this will be 2. And there is a minus term, sorry, this is a plus term, not the minus term. Okay. This is the acceleration at t is equal to 0. Okay. No, I think I have made some mistake over here. This is not this is plus delta t is this value, this is 1.8. okay, so this value is basically 1.8 and this value is basically 2. Okay, so if you solve this, so it's a simple expression. So what you are going to get is the velocity at delta t. So t is equal to delta t. So this value is coming out to be 0.38. Okay, so this value I'm going to write down 0.38 over here. And lastly, we need to get the displacement. So the displacement at delta t can be calculated using this expression over here. Okay, and I just need to substitute the values. So here you can see this is the value of the velocity, oh sorry, this is the displacement at t is equal to 0. So displacement at t is equal to 0 is over here. So you can substitute this value straight away as 0. Then we have the delta t term. So your delta t is basically how much? 0.2. Okay, so this is 0.2. This is the velocity at t is equal to 0. So velocity at t is equal to 0 is already 0. So let me write down 0 over here. Then we have a8 term. So a8 is 0.0067. Then we have the acceleration at t is equal to delta t. So acceleration at t is equal to delta t is 1.8. So this value I am going to substitute as 1.8, and this is the acceleration at t is equal to 0. So acceleration at t is equal to 0 is 2. So this value is basically 2. So if you solve this, so you are going to get what is the displacement at delta t. Okay, so this value is coming out to be something like 0.0386. Okay, so here I am now going to write down 0.0386. Okay, so in this way you have to get the response of the structure for the first step. Okay, so now you can use the similar equations for calculation of the response for the another remaining steps. Okay, so let me write down the expression for you so that you can solve them. Okay, so the very first expression is the calculation of the effective load vector. Okay, so now I am working on time as theta times 2 delta t. Okay, because you won't be getting a response, or you won't be getting the values directly at 2 times delta t. So equation is going to give you the values as theta into 2 times delta t. Okay, so here if you refer the earlier equation, so every time is in now incremented by the delta t term. Okay, so जहाँ पर भी पहले delta t था, now it is 2 times delta t. Wherever the time was 0, now it will become delta t. Okay, so the same expression can be incremented by 1 or incremented by delta t, so that you can get what is the value of load vector as 2 times theta delta t. Okay, so if you substitute these values, so this is going to give you something like 69.97. I'm intentionally giving you the value so that you can do the calculations later on. This is just for your check. Okay, 69.67, not 97. This is 67. So this should be 67. Okay, then Correspondingly, you can solve this expression, that is the effective stiffness matrix. So if you solve this expression, you are going to get the value of the displacement at theta into 2 times delta t. Okay, so this value is coming out to be something like 0.212. Okay, so this is how you will be getting the delta t or the displacement at theta into 2 times delta t. Okay, तो हमको तो क्या चाहिए, हमको तो 2 times delta t चाहिए, है ना. So for this purpose you have to use the expressions given in the method. The first expression you will be getting is the acceleration, because in this method acceleration is calculated first, and based on the equations, so now you can get the acceleration at 2 times delta t. Okay, so if you solve this, so you are going to get acceleration value as 1.603. Okay, so then you will be using the expression for calculation of the velocity. So calculation of the velocity, the expression is something like this. It's a very simple expression, and if you solve this, you are going to get the velocity at 2 times delta t. So its value is coming out to be 0.72. And lastly, you can get the displacement. Okay, so the most important part is the displacement part, and this displacement can be calculated using this expression. And if you solve this, so you are going to get the displacement at delta t, or rather 2 times delta t, and its value is 0.14 and 9. Okay, so like this you can proceed ahead, and you can go for the calculation of when time is equal to 3 times delta t and so on. Okay, so this process continues, and you can get the response of the structure for the entire time period which is required. And if you do all these calculations, so at the end you are going to get a table which is something like this. Okay, so here you can see again the displacement is increasing, the velocity is also increasing, whereas the acceleration is decreasing with the increase in the time. So the response is very much similar, only thing is values can be little bit different if you compare the other methods. Okay, so this is how this Wilson theta method is going to work. I hope you have understood this. Please try to solve the problem by yourself. All the values are there in front of you. Okay, is it clear to everybody now? Any questions, please? Yes, yes, any questions, please?
No, sir.
Okay, so shall we stop now? Shall we
Yes,
stop?
sir.
Okay, let me stop the recording.